So our next session, last session before the mid-morning break at least, is Conor Murray. Conor has a lot of accolades. I'll introduce Conor as the chair of the ICCCS, the International Confederation of Contamination Control Societies. And he's also the chair of the Irish Cleanroom Society and a technical expert on a number of committees. Focus today is microbiological standards, so pharma GMP and the link to ISO 14644. And I'll let Conor give the introduction and take the floor.
Tim, just checking, is the volume okay on the mic? Can you hear me okay at the back?
Yeah, I heard you.
Good, okay, so good morning. It's interesting to make the transition to this, that I'm going to talk about microbiological contamination control. The reason the word control is in there is because we need to recognize that in the world we live in, whether it's food or hospitals or GMP, we're dealing with the environment. So a lot of the standards I'm going to talk about in the 4644 talks about clean rooms and associated controlled environments, okay? But the word control, remember, talks about different things, right? So here's some of the hot topics that's around at the moment. So because I'm going to talk about standards, I'm not going to talk purely about life sciences and Annex 1, which is clearly a very big topic. I'm going to talk about some context around hospitals where the patient in an OR is full of contamination, but it's their contamination. They don't want it from the surgeon or the nurses or the cleaners, right? The same way food, it's about we're orally ingested. We don't want to discover we can't go to work the following day because everyone gets sick. So there's a lot of stuff going on in that side of it, right? But it's really important to recognize as an overview that we can control the environment because we can measure it. We can measure total particles, we can measure pressures, temperatures, humidities, flow rates. Okay, when you get to microorganisms, then it's a different matter because we don't have a situation in any type of clean room or clean control environment where people turn around, right, and they say, I'm a bacteria, and they wave to you in the corner of them and say, hi, I'm over here, I'm a contamination, I'm an unwanted microorganism. They don't do that. And we've real-time measurements in particle counters, but we don't have, outside of biofluorescence, which are coming on in ARMM. Okay, so I want to take you on a journey today, and I'm going to poke you in the eye, and I want to change the way you think about clean rooms. Okay, and I find that I first of all have to say these are my opinions. Okay, I hope a lot of other experts, so Tim is one, you have lots of experts, you have Pauline I see here, there's many I've met during today. I've just come back from the Nordic conference in Copenhagen over the last few days, and so we experts get together and tell each other we're full of shit. We challenge each other and we tease things out. So we're technical nerds and we do a deep dive into stuff, right? But I think what's important from a microbiological control perspective, and I'm convener of a working group at TC209, I was the one for EN 1741, and we're trying to bring microbiological control or cleanliness or unwanted microorganism into the family of 14644, okay? So the old titles were biocontamination control, but remember it's within the wider context of a contamination control strategy. I use the word plan there because before the word strategy came out in 2015, and you do realize that Annex 1 paper was in 2015, okay? So the word contamination control strategy is not a new term. I used contamination control plan for years, and I had to change it after 2015 and then call it a strategy, okay? The reason strategy is used, I assume, is because it's a holistic view within Annex 1 to talk about it's connecting the dots. Okay, so I'm going to talk about some challenges very quickly. Again, because of the time we have here, and we've had two presentations, and these are kind of heavy duty, so I'm not surprised you're not asking any questions because you're looking like this here and bamboozled by information. So that's why I take people on a journey. I want to change the way you think about these. But when you can't sleep at night, pull out some of these presentations. They're guaranteed to put you to sleep. But guess what? In the morning, subconsciously, it'll feed into you, and you'll become more of an expert than you think you already are. And most people here are already experts. We just have different perspectives on it, right? So there's, and I'm not going to read the slides, by the way. I'm going to tell you a story. You can read what you want in it, okay? But I'd like to point out the last one in there, right? There's an awful lot more lifestyle drugs. So you can see from my side, I like food, I like wine. myself, my wife entertain with our children and grandchildren. And I'm on lifestyle drugs. I'm on statins. It's a bit like the Matrix, the red pill or the blue pill. Which one do you want, right? So the world has changed, right? And we want to feel better than well, okay? We're now in the space where I want to feel better than well. I want to continue playing squash and tennis and paddle tennis way into my 80s and 90s, right? Okay, so we've limits in our mortality, but we expect drugs and replacement organs to take care of that in the future, okay? So back to microbiology, right? I'm an engineer, but I work with lots of microbiologists. And I've learned over the years that clean rooms are made up of engineering controls, people controls and behavior, and ongoing cleaning and disinfection. And that, by the way, is the reason the table is no longer in the -4, because there was too much focus on murdering clean rooms with air and not understanding behavior, process issues, and cleaning and disinfection. And I know I see Jim Pollerine here from Steris and Uvicolab are all talking about the importance of cleaning and disinfection. So the -5 that's being worked on is heavily going to go into that area, and the working group 2 on the update of 14698 and 17141 is going to focus on that. Notice the last line in there, the microbiologists that I talk to in aseptic areas spend their lives counting zeros. And they go, oh my God, I don't have a zero. Oh, and they find it out when it's too late. Now they've got to go back and do a deviation report of something that may or may not have happened a week or 2 weeks beforehand, and they're struggling to try and find an answer. So they've got a difficulty in putting a kappa and a deviation onto it, because the data they're getting is late, and they don't know what it means all the time, right? So, okay, so engineers, we're lucky because we can do real-time measurements using particle counters, but we can't tell what it is. So we can't do the nature, the origin, and speciation, and we don't know the risk or the impact. Okay? So we're talking about QRM. So that's going back to Annex 1. The first thing Annex 1 talks about is quality risk management, risk and impact assessment, and a contamination control strategy, which is everything that goes together, right? And one of the drivers in it, of course, is ATMPs and short shelf life products, because the Annex can't stand still, right? And the other one that's interesting is that they're now talking about advances in new technologies. So you'll notice CFUs, there is an alternative. If you have a better alternative that's more real time, then we're allowing you to do that. So they talk about ARMM. And they also talk about the importance of good design, okay? So this is where this connection, where I'm going to talk more about this morning, is around the move to a -20, which pulls together the old 14698 and the European version of 17141 in the context of a wider contamination control strategy, which can be applied to hospitals, to food, to microelectronics, okay, and medical devices. So it pulls those together. But as Steve said earlier on, it is based on the engineering controls plus people controls and behavior and gowning and ongoing cleaning and disinfection. And I'll go back to the table. Table B2 is gone out of the -4 because people were not looking at people and materials and process and behavior. The gowning levels have a huge impact on your removal. Because remember, if I have filters in the ceiling, I ain't getting any particles coming into the room. So where are they coming from? They're coming from materials coming in, they're coming from people coming in, and they're coming from operations. If you don't do ongoing cleaning and disinfection, everything's in there stays in the room, and you walk across and you democratically redistribute it back into the space. And no amount of air change rates or air changes or air volume flow rates will have any impact on your control of your product or safety if you don't do ongoing cleaning and disinfection. Okay, so I think that's part of the answer I'd give you why the table is gone, because it allows people to go for table and think they're safe. No, you're not. Okay, if you have 5 people or 15 people, if you have a closed process or an open process, they dramatically affect the product quality. And if you're still killing it with air, you should spend the money somewhere else in terms of training and operations. Okay, so there's many applications in terms of microbiological contamination control or microbiological cleanliness, whatever way you want to talk about that. So very quickly, some of these are the following, okay? Okay, so obviously life sciences in pharma and biopharma is really around product quality and patient safety. And guess what? There's enough regulation in the world today between aseptic guidance from FDA 2004, the new Annex 1, which is now a PICS document. So it's now worldwide of all the countries involved in the inspector cooperation scheme. Okay? And the good news is the new Annex 1 refers to 14644, of which there are many dashes. That's the bad news, which I'm going to show you now in a moment. Okay? So again, in life science and medical devices, it's a device where the bulk of them are terminally sterilized. Okay? So they're less concerned in those areas about the number of particles. They're looking at low bioburden. Okay? But then you have combinational devices, and you have various devices that are close to the central nervous system, which means they're on the other end. So you have a lot of variety in that. So a lot of the work we're doing in the working group talks about the difference between medical device and challenges versus aseptic or terminally sterilized in terms of liquids. So you've lots of directives, but you've also got ISO 14971 on risk assessment. You've 13485, and you'll notice I'm using all these acronyms. In this industry, you're stuck with numbers: 14644-1, -5, -20, 14971, 13485, 12469. Now, I haven't even been into the BS standards now, but you've got tons of these numbers which you have to know and be available about, okay? Again, in our working group, we're dealing with the challenge in low bioburden products. And the concern is that there's too much life science pharma regulations coming in, imposing unnecessary guidelines for microorganisms in medical device that are being terminally sterilized. So we're trying to deal with that in the working group at the moment. Going on to hospitals, hospitals combine a number of things between laboratory side and the patient side. So you need to distinguish between patient-centric and lab operations, which are more GMP and life science related, okay? So infection control becomes a big deal. So nobody could say that a OR is a clean room, but it is a clean, controlled environment. So we're being very careful in the new standard to separate total particles from microorganisms, how we deal with those, and there's the challenges in that side of it, okay? So you're dealing with all those areas there, and then, of course, you've biosafety kind of thrown in with this, and tissue culture and labs and sterilization devices, gowns for reprocessing, this sort of area here. Again, I'm not going to read the slides. I'm just trying to pull it together to give you a context for the story I'm telling you. Okay, but food is interesting because, you know, like we want to feel better than well, we want to eat food that looks really nice and really fresh, but doesn't have artificial preservatives and doesn't have coloring agents, which are artificially colored to make it look nice, but it's actually unwanted and unnecessary, in my view, a contaminant, because it's not adding to the product. It's trying to protect it from the unwanted of food spoilage, okay? So food quality becomes very important. You're worried about things like pathogens and also yeast and molds that change the nature and color and the taste of it, okay? So the overall objective in microbiological contamination control is that you actually has a real impact on the cost of foods in the way they're manufactured and processed, okay? So it's about unnecessary addition of artificial preservatives or coloring agents, okay? And in the manufacturing side, you want to drive it down to low production costs, increased shelf life, and increased visual presentation. They all matter in terms of cost and also price in that area. Okay, so again, let's go back onto the old story on microorganisms. They don't say, hi, I'm over here, and I'm a virus or a bacteria or a yeast or a mold. And we talk now sometimes about MCPs, microbe-carrying particles. And certainly Bill White was involved in that, and we've got Nicola Bench and Tim Eaton on the experts from BSI, among others, and there's a mirror group where this information will be shared with you over the next few months on a committee draft we're developing on the new -20 on it, right? But it just shows you the different sizes. I like using this slide because, remember, COVID came out in 2020, and everyone was saying it's on the surface, and all us aerobiology experts say, no, no, it's in the air and on surfaces. And 6 months later, finally said, okay, it's in the air as well, okay? And that's because of plumes and very small particles either go in skin flakes or we exhaust them out into the air through discussions. So choirs, my sister's in 2 choirs, and they got shut down very, very quickly because they're singing outward and they're spreading out the plumes of air with viruses in it, okay? So I talked about three things earlier on, which Steve talked about earlier on as well, about engineering controls, people controls and gowning and behavior, including materials coming in and all that, as well as cleaning and disinfection. But in terms of pulling those together and this holistic approach, whether it's a contamination control strategy or how you deal with the environment, you have to come up with two things. You have to establish control, and you've then got to demonstrate I'm in control. And that's part of where the standards come in to help us on this, right? I've also used the word state of control. So if I have microorganisms and I have difficulty measuring those, then I can't say I'm in control of microorganisms. I have a state of control. But if I'm in an environment, I can control entry areas, air volumes, temperature, humidity, differential pressures, cascades. I can control those. So you need to keep in your mind an environment and the microorganisms. Now notice in ISO standards, we don't talk about the process. So I want to just talk about the environment and the actual microorganisms themselves, of which we can't always see where they are. Therefore, we can't necessarily control them directly. So we've got to be careful of that. Okay. So again, this is stuff around contamination control, alert levels, all that stuff, formulate strategy. I'm not going to go through the detail, but that's the context of what we mean establish control. The same way in demonstrate control, it's like, as I learned from my microbiologists over the years, the trend is your friend. And I said, well, okay, you've got a limit of 200, say, in a grade D area. And does it matter if I was 20 and now I'm 120 the following day? And they say, yeah. Why? Because I don't know for sure that it's 20 or 120 in the first place, because it's an indirect measurement. So microorganisms in traditional ways is sampling. You're sampling, okay? Not measuring, you're sampling, you're incubating, and you're enumerating a colony-forming unit, a CFU. That's not the same as saying, oh, that's a virus, that's bacteria. Now, there are growth methods, MALDI-TOF, Chelsea systems, which are into the growth-based ones, and PCR, but they're not necessarily for routine use. They're laboratory-based. Okay, now you have some stuff in biofluorescence, and that's becoming more and more popular. There's a number of vendors in that area where you're measuring AFUs, active fluorescing units, but it is real time, and it's a really great area to be in. And the Annex 1 has opened the door to allow those to be talked about. So keep an eye on those, okay? So we have this box in a box, the onion principle in -4, but I've been using more and more over the years what I call this the Swiss cheese approach. And what's interesting is Annex 1 says, by the way, that it does not expect one measure on its own to do the job. It expects a number of measures that collectively together give you a contamination control strategy that protects product quality and patient safety and well-being. So I've listed them down there, the facility, the controls, the behaviors, the QMS. None of them are perfect. But when you put them all together, you're hoping that the holes don't join up and your critical quality attributes of the various items there are the ones that work for you. Okay, so that's another way of looking at that. Okay, so everything starts at QRM, it's a hazard. I'll make the point that hazard is the potential to do harm. Okay, so if I have a product, I'm looking at failure rates. In the environment, it's a hazard. So HACCP is a more effective tool in QRM than FMEA or FMECA, as in failure mode analysis, right? So some notes there for you, right? Again, I finally get the dashes, but I was afraid to show you some of the stuff earlier on because it's this. Can you imagine if I showed you this at the start of this presentation? You'd say, oh, okay, I'm out of here. To hell with this. I'm not going to go through 20 dashes, okay? But this is the range of the 14644, okay? But bear in mind that it covers things that are in air and on surfaces, and it covers total particles, microorganisms, chemicals, nanoparticles, and macroparticles. Okay, so that'll give you an idea of the history. And notice we have, and I'm not sure if this pointer works, it does great, okay? So -4, updated in November 2022. So a number of us were involved in that working group from different countries. Okay, the -20 is down in here. It's in revision, oops. The 2003 was 14698. It's now in working group 2 on revision, okay? But there's lots of them in there, right? but they're not all relevant in your area. But because ISO standards sit up there in the sky looking down 10,000 meters, it's got to cover a lot of different things. Okay, so the key ones really here are -1, which is for cleanliness in air, remember air. Okay, -2 is on monitoring in air. Okay, and -3 is measurement methods. And then you have various ones there coming down, and again, the -20 is down in here. But there are, as Steve said, published November 22 -4, but there's 2 in current operations, -5 operations, and -7 separative devices. In our life science world, we talk about RABs, we talk about isolators, but in ISO, we keep them out because in semiconductors, guess what we call an isolator, they call it a tool. Now, I have to say in Ireland, the word tool is not the same interpretation as tool in the States is, but I'm not sure. That's the language issues. What's it, 2 countries separated by a common language, right? Okay, so again, really important here. We cannot control microorganisms. Like young children, okay, and a lot of adults, we can't control them. We can seek to mitigate their impact. We can influence how people intervene. Oh, there's an ample I'm just going to put in the tweet and move them around, and nobody's watching me and they won't know the difference, okay? That's why we've got isolators to separate people. But we haven't advanced how we deal with that since we put isolators in. And that's where we've got this over-regulation to some extent in life sciences that we've got to move away from. And that's why food people don't like talking about Annex 1 the same way in hospital and particularly medical devices. But we can control the environment. The engineering controls, we can remove people, reduce people impact, and we've building management systems, facility monitoring systems. We've gowning mechanisms, we've behavior, we've intervention, right? We've telemanipulation, we've gloveless isolators are becoming much more popular now, right? And you've ongoing cleaning and disinfection. Okay, so in the working group 2, we're toying around with changing the words definitely from biocontamination control. And we're talking more about management or assessment of microbiological cleanliness, unwanted microorganisms, quality. So the new word will be not biocontamination control. It may be something like management of microbiological cleanliness, okay? Or it may simply be management of unwanted microorganisms, because ultimately that's what it is. You know, bad bugs would have been the old term of the FDA, right? Okay, so I'm going to move on to point out to you this. For those in Annex 1, you may remember this table, okay? There's the 2029 that's now gone out of from -1 in 2015. This goes back to 2008, okay? Except the difference is the left-hand side is total particles, deals with classification. And the right-hand side is microorganisms, which is monitoring, okay? But people confuse the two by putting them together. So guess what? That table never existed in Annex 1, never. We, the people, put it together in some fashion over the years, and then it's been used commonly in lots of different areas on it, right? It was constructed to show the linkages between particles like grade C. It's an ISO classification, okay, of 7 at rest, 8 in operation, and it's got microorganisms that you monitor, okay? Notice I put the X's through the numbers from the -1 standard on it, right? But it confused people. So I've heard lots of people say, I have a Class A environment, I have a Class C environment. I said, no, there's no such thing as a class environment. It's an ISO environment for total particles, and then it's monitored. Okay, so again, I want to just touch on those. I want to just change the way you think about clean rooms, right? So again, the first clause in Annex 1, just to show you, because clause 1 is about scope. Clause says, facilities, blah, 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 appropriate designed, qualified, and valid where applicable, ongoing verification, relevant sections of GMP, blah, 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 and the use of appropriate technologies. Go ye out and apply ARMM, right? Best available science. And I really like the bottom of it there, go to 14644. So we spent years telling Annex 1, the revision from 2015, giving comments. There was thousands of comments, trying to get them to grab the standards as references, okay? So I gave you 20 dashes, okay? Here's a simple way of looking at things here, right? I'll jump to this one first. You have a simple matrix. You have airborne or surfaces. And either vertically, you have total particles, you have microorganisms, chemical, nanoparticles, or macroparticles, right? Microparticles are very important in space because of mirrors, okay? The James Webb Telescope, the Hubble Telescope, really important parts of that side of it. Also have mechanisms in microorganisms because microorganisms carrying particles are typically 10 to 25 microns and larger, and whereas otherwise we're measuring with real-time particle counters, typically max out about 10 or 15 microns. It's between 0.5 and 15. And we talk in Europe about 0.5 and 5 microns, whereas some of this stuff here is much larger. So we need to be careful that we don't have one shoe size fits all. Okay, and again, when you took from a microbiological perspective, you can be from 0.1 microns, and viruses are around that range, all the way up to yeasts and molds. Okay, and the control of microorganisms is through those mechanisms of the engineering controls and the people controls and gowning and cleaning and disinfection. So notice I'm rounding, I'm doing a deep dive, and I'm going back up, top down, and bottom up to change the way you think about clean rooms. Okay. So one item that came out, and Steve pointed out in the -4 about commissioning is the totality of everything, which includes test, adjust, and balance. It includes also test reports and certification. One of the things I've been pushing in Ireland and elsewhere for many, many years is I don't want a clean room test report. And by the way, you're not a clean room validation engineer. You don't validate a clean room, by the way. You qualify a clean room. You qualify equipment and facilities. So read Annex 15 on Q and V on it, right? You validate a process or a product. So if I have a cleaning equipment, I've qualified the equipment to clean, but I validate the process of cleaning. It's a different, okay? That's a bugbear of mine, so forgive me. I get really annoyed when I meet clean room testing people and they call themselves validation engineers. Say, you're not a validation engineer, and they validate clean rooms. You don't validate clean rooms, you certify clean rooms. So I'm suggesting this is how you link the 14644 standards. I've put in blue the -20 because it's not out yet, but in the future, you want people to say to you, yes, I've taken into account the standards to design it for microbiological cleanliness in air and on surfaces. And I've applied -4 and -16 and -3 and all these other dashes, but they're the relevant ones here. I've probably missed a few of them, but they're minor players in it. And again, finally, it's certified to -1. If you call a clean room, you must certify it to -1, whatever that is. Call it a clean control environment, and you don't need to apply -1. So in our working group, we will have a clean control environment. So if you don't want to have anything on particles total, and in food, you're only interested in pathogens, you don't have to say it's a clean room and total particles. You just stick to unwanted microorganisms. And again here, I've just stuck in here that the 5 microns is gone out of that. So again, this is the stuff that Steve talked about. I put this context together. So when you look at it, you'll see the totality of that, even though Steve has talked about that. Interesting in -4, I want to just go through one item in here for you, right? User requirements. You should not tell somebody how many air change rates you want. You tell them what you're doing. You tell them how you're gowning. You talk about the process. What do we want to achieve in the clean room? What am I making? Why am I making? What are my regulatory and accreditation requirements? So what's the purpose the business need? Other attributes. What the users want, not how to. Guess where the how-to comes in? The how-to comes from the concept design, the basic design, and the detail design, and you're in this continuous review, which comes from the standard on it, okay? And then, of course, change management, right? People think things do not change. Everything changes. The question is how we manage change. So this is just to reinforce what Steve talked about in his earlier paper. A really important document, -4, a really, really important document. It talks about air volume flow rates for contamination removal, effectiveness. That's what you need to talk about. And that's made up of gowning and material and the nature of the process. If I've got a closed system, why do I need the same number of air change rates than if I'm in a septic system? And by the way, in Annex 1, sterile medicines can either be aseptically processed or thermally sterilized, and you apply Annex 1 differently in those contexts. And then, of course, Commissioning, getting to start up on time, first time. If you do not commission your facility, you'll spend 6 months messing around with it. So there's the construction plan and your commissioning. Okay, I call it setting to work. And finally, you need your certification coming out of that there. Notice the word DQ, IQ, OQP are not used here. We use the word verification. Testing. What am I accepting? Because when you build a clean room, it's a contract. I'm putting a wall in, I'm putting a drawing in, and you go off and you verify it's against the drawings and specifications. You scare and confuse people when you use the word qualification and validation. I'm not saying contractors don't understand it, and you guys are all in this area here, but you really need to get it down to verification and then understand you're part of a wider plan, okay? So again, dash 16 is very important on that side. I'm not going to talk about that, but keep in mind, air volume flow reduction rate is the biggest way of saving money in a clean room. Not that you waste the money, because you're wasting it now. Spend the money on something better, like training. Okay, so I want to go back to a few things in here. I'm not going to go through this because this relates to our famous 5 microns. You all know this table here, table 1, and you know not specified. And then they talk about it was 2029. I find this amusing here, forgive me. Sorry, forgive me, I want to show this. That's table 5, by the way, which is monitoring. Okay? Monitoring, not classification. Let's go back to here, if I can, if I go back. Sorry, forgive me, I want to just go back to this. Sorry, I'm taking too long. Oh, come on. Sorry, I've got to go back here. But 427 says for clean room classification, okay? Classification not the same as monitoring. You classify clean rooms because you can measure them, you monitor with microorganisms, right, okay? So you measure 5 and 5 microns, okay? That's where the confusion starts coming in, right? But we said back in 2015, on larger particles with small numbers doesn't make any sense, which is why it's gone out of the table. That's just background when you want to read it separately, why it is there. So it's not specified, okay? But it is required for continuous monitoring and at table 5 for monitoring, okay? No change, it's 29. Okay, now here's where it gets a problem. It's not specified, but then they put in here, classification including 5 microparticles may be considered by the CCS or historical trends. Cowards. We told them for years in 2015, take it out and say, yes, we will, and they did, and then they slipped in this little note in here. So what do people do? They still classified 5 microns, okay? It should not be used at ISO 5, right? Because you're going to do continuous monitoring anyway, okay? And the problem is, oops, I missed the 5.9, forgive me, it's here. Yeah, sorry. Watch clause 5.9. You're in ISO 5, you're going to get caught with 5.9 on tube links. So there's a new technical report coming out in the next few months from us, a number of here are involved in the working group, which talks about tube length is only one item. Tube diameter, the internal surface roughness of the tube. More important, number of bends are important. There's very few RABs and isolators where you can have no bends and a short tube length in all cases. So if you want to classify at 5 microns, you're going to get caught by 5.9, so be very careful on that. So, okay. And again, another interesting one for you. You don't need to take 1 meter cube sample volumes at each sample location. That's classification. This is monitoring. I just want to, and there's a load of stuff in here that I'll go back. But here's one I'm going to kind of finish on, because how much time have I got?
You're okay for another 5 minutes?
That's okay, that's fine, because I want to, this is one, by the way. Who's got a, whoops. Who's picked this one up in clause 430? Unidirectional systems should provide a homogeneous airspeed in the range of 0.36 to 0.54 at the working position. And by the way, reference on how you do this is in 14644. So dash 3 says 30 centimeters up here, below the filter. Okay? Where's your working position? It varies depending on your process. So now you're required to get 0.36 to 0.54 up there and down here at the same time. Okay, and then it says here, forgive me, there's no inspectors here, are there? Okay, good. Okay. We had a Danish guy yesterday, and I did say this to him, right? And he said, hey, I'm only one inspector at Denver. We didn't agree to this, but it had to go in because it's a PICS document from everyone in the world on it, right? And then it says airflow visualization studies should correlate with the airspeed measurement. Now again, you can see I'm a technical nerd. We do a deep dive into this stuff here. And this is just bad science on it. So the good news is, here's the answer. Okay? It's like I baked this cake beforehand, right? Now, let me pull it one and just now. This is what it looks like when it's done right, okay? So yes, you do your measurement below your filter face. Your 6 inches, 150, right? So working position, you follow this and then use airflow visualization to demonstrate first air. It's unidirectional. It comes down. There's no particles in here. You show airflow visualization over the working position. First air and flushing affect the working position, and while airflow vis studies may correlate with air measurements, there will be variations if you have eddies and turbulence around the working position. Any measurements I've always done is the vectors are all different because you have bounce effects, and typically they're 0.15, 0.1, and they're all over the place, okay? But you put a lot of effort in to try and show those on it, right? So I'm just giving you, you'll get the slide. I've been doing training on this now for the last 6 months with various companies on it, and I'm giving you the answer where there's bad science on it, okay? So again, Steve talked about the recovery rates. Very important to know there's a difference between cleanup time and recovery rates, okay? 429 talks about cleanup times. 14644-3 talks about recovery rates, which are not the same. They're similar, but they're not the same, okay? And it's important here because there's another problem I have with clause 432, which I'll show you in a moment, is, and again, I'll let you read that separately, is notice here, this is 425 on qualification. This is requalification 432. And then it says, in this note here, for grades with non-unidirectional flow, a measurement of recovery testing should replace velocity testing. Now, that's just bad science. The equivalent of air velocity test in grade A in unidirectional flow is air volume flow rate. It's not recovery test. And when you do recovery, you've got to put a challenge in. So you're now contaminating your grade A environment, contaminating, because you've got to put something in as a test aerosol to look at the recovery rate on it, okay? And I'm suggesting, as others are, that you use cleanup time. Again, I'm just venting a bit on I think it's a very good document, but there are certain areas where they didn't listen to us scientists and engineers and microbiologists and came in with this. The good news, of course, is if you look at Annex 1, it talks about should, okay? Should means should consider. I pity anyone in Asia because when they translate the word should, it means shall. They don't distinguish between should, consider, and shall. The reason should is in Annex 1 is very simple. You've either aseptic or terminal sterilization. The more you do aseptic, the more should be shall, as in I should do it and must do it to make it work. And the more we go to terminal sterilization is should consider and then say, nah, I don't need it, because my data gives me that from terminal sterilization, okay? So that's just some background stuff to you in there, right? And again, I'm going to finish now on airflow visualization is a big deal in Annex 1, okay? But the biggest important, and it's mentioned 4 or 5 different places on it, right? And this is just to give you one of the key things in airflow visualization is, and I know there's a number of stands here, neutral buoyancy is really important. If you don't have neutral buoyancy, then gravity will pull it down and it gives you a mimicking that is actually working, but it's not. It's fooling you, right? And there's a lot of stuff in the FDA guidance of 2004 and CETA and other ones in relation to this. So that you do studies within, in my view, within grade A environments, and then you do patterns outside in grade C and D. And that's where air change rates goes out the window, in my view, because it's airflow patterns. You're removing contamination. So where's the process? Where's my air coming in? Where's it going out? How am I diffusing the air are really important factors, Okay, and again, there's different types. So again, it's important neutral buoyancy, and again, I'm going to point you back to here. Very quickly, there's an example of a fogger this particular one in a particular conference room, and it's hard to see, unfortunately, with the quality of the photograph here, but the actual air is going down, but there's no diffusion in the ceiling at all. Here, there's a great way of showing the air going down, but the actual unit, the UDF unit, is not working. It's switched off, but it's mimicking, it looks great on it. So CFD is really important, but you need to marry CFD, as in computational fluid dynamics, around airflow patterns and studies on that side. Okay, so there's notes from FT from 2004 around crucial that airflow patterns are valued for turbulence or eddy currents that act as a channel reservoir for air contaminants. That's out of 2004. You have guidance on USP 116 on it. Visual movement is subject to process, but it's one step in the effort, back to this holistic view in Annex 1. CETA in the 2022 version gives you guidance on airflow visualization. These are all really important because the inspectors know this stuff. They're going to ask you, when you say you've done airflow viz, they're going to say, well, what did you do? And the first question they're going to ask you is it neutral buoyant? So be prepared for that following August, right? But the CETA guidance is very good, but they're all mimicking good scientific guidance on that side, right? And again, that was a comment I made. I'm going to finish off on that. That's the one that probably gets all of us ISO standard people going at the moment, where you're trying to do it at the working position and at the filter phase. And there's just some pictures of airflow visualization. And I told you I was going to tell you a story, get you on a journey. I want to change the way you think about clean rooms. Okay, it's not meant to be an examination. It's trying to get you to think differently about it. There's lots of exhibitors doing lots of different things out there that cover both engineering controls, both cover people in gowning and behavior, and people coming in and ongoing cleaning disinfection. I'd get out there and talk to those people because you're all experts in this area with a different view from a different perspective. I hope that's giving you a tour around where the dashes in 14644 can help you in guidance. Thank you very much.
Thank you, Conor. I think Conor said if you're laying awake one night, I think you need to develop insomnia to read what Conor writes about all this subject. But
wait to get Tim's later on and his ones as well, right? We're all technical nerds.
A wealth of information, so thank you. Would anybody like to conjure a question out of any of that for Conor? Anything to clarify? Steve?
Quick. I'm off mine now. Only a quick question, actually, Conor. With regard to Part 20, how long a process is that for that coming out into the market? Because I know we've got a European standard, and it's going to replace the ISO standard. What's the process? How long is that going to be?
Well, the process, we've had 6 meetings so far. We met in Paris last week. We're preparing a committee draft at the moment. What's really interesting on it in the -20 is we're changing the title, so it's about cleanliness or unwanted microorganisms. We're focusing very much on people because the people create most of the contamination. And we're massively distinguishing between the need to have particles and microorganisms together. So that so if I'm in food and I shouldn't necessarily be worried about particles in a way. I'm more interested in what the particle is in terms of microorganism. Okay, and that applies in medical devices where you have low bioburden products and you have product metrics on particles, right? But the real issue is control is microorganisms and low bioburden because you're terminally sterilizing, okay? So we're trying to focus on those different areas. We have a number of different subgroups going on, but it is a real enhancement of even of the 1741 in a way in terms of giving guidance. And it's linking operations in -5 on cleaning and disinfection as well into that area. So yeah, but I would expect the CD, and I'll finish on one point. The current ISO strategy is do not wait to the draft international standard before you go out to public comment. Okay, they're saying at the committee draft stage, go to your national mirror groups, and you'll have this through LBI 30, which Steve is chairman of that, and talking about that and sharing with everyone here what's your view on what it should be. and then you get a national perspective on that among other countries, and we get a good committee draft. We may take 2 revisions of that, but the first committee draft will be out this year, and you'll already have selected chairing. So work through your LBI 30, work through your industry groups on that side of it. We spent too long going to a draft international standard, and then it takes thousands of comments when people are only allowed to get involved. So then now we're bringing in the consultation process much earlier in, but it's through industry groups, not to the general public. It's in industry associations on that side. Okay.
Yeah, that's a really good comment. So through people like Steve and I and others that you might be connected with, we represent the Contamination Control Network, I represent PHSS. So any of those organizations that you're a member of, then please look out to those websites and those communities, because we will publish committee drafts and ask for feedback and information. So if you're not a member of any of those industry groups, that's the encouragement to join and participate. Don't wait.
I think that's a really important point. And Tim is chairman, forgive me, of the Contamination Control Network. Steve is chairman of LBI 30. There's a huge wealth of knowledge in the UK. You need to get your voice heard. So get talking to these people and get involved, and they will share information with you during this year. Tim Eaton and Nicola Bench are the 2 key ones coming from the UK side.
Yeah, thanks, Conor. Any final question for Conor? Everybody's holding their bladders tight, right? Jason. Shout out now.
Thanks, Tim. Not more of a question, but more of an observation. I've been in the contamination control monitoring industry for nearly 30 years. One of the biggest problems I see is the misconception between certification and monitoring, and the application of the certification tables to the monitoring process. And with the monitoring environment, it's really all about trending. And I've seen so many companies make mistakes of applying the certification numbers to their processes on the 0.5 and 5 microns and have a one-off spike. And now, according to their SOPs, that is an out of tolerance, and they send people into the clean room to find this anomaly that they never find. So you're introducing contamination into your clean room already before you even understand what the problem is. So all I just want to say, just understand the differences between certification and monitoring. And I think that Conor did a good job in highlighting that in the trending. It's all about the trend.
So just to reinforce what you've just said there, Jason, is that when you use the word certification, that's the word we use as classification. And that's why the 1 meter cube per sample location came out from classification. You don't need that in monitoring. You need a slice at a time. You need trending on that side of it, okay? So it's really important, monitoring, and in a working group, we're now looking at the word monitoring, including things like testing, measurements, right? It could be root cause analysis, it could be an investigation. It doesn't have to be a monitoring system, continuously monitoring or at fixed intervals. So in medical devices, low bioburden, they may want to do a look every 6 or 9 months because they're doing product metrics and they're doing VD max in terms of sterilization of their controls. So we need to spend our money where it needs to be, and that's where fundamentally the QRM and in -2 and in -4 says, where's my risk, where's my hazards, what do I need to do to make this work? So that's why the good science is being applied to this.
Thanks, Jason. Conor, thank you again. We'll stop there for a break.